And it's a pleasure for me now to introduce to you David. David is a Symfony expert, and he also works on Jackalope, which is a content repository implementation, PHP. He does a lot of traveling and talking, and those of you who were yesterday attending his workshop might have already noticed he's a very charming speaker. So, ladies and gentlemen, I present to you David Buchmann.
So good afternoon. What I want to show you today is getting into details of caching. I've done a couple of talks on like the introduction to caching, and realized I want to show something more interesting, that when you have an idea of the basics, that will help you get further. And well, one thing that is particularly tricky to cache and needs more thinking than just like, oh, can I cache it or not? Can I cache it for 5 minutes, for an hour? Is when you start having logged in users, what to do, how to cache that. Just a very quick reminder, like why caching? So essentially, what you want to optimize with the caching is scalability and response time. So we're talking HTTP caching here, not like application caching like Memcache. So what you want to cache is the whole rendered output, so that you can deliver it very fast if you need it, again, the same output. If you have like a broken application that's horribly slow, caching is kind of a stopgap, but it's not the solution. You need to fix the application. The point of caching really is that you can have a lot of users, or that you can get like really, really fast response times compared to the normal response time you would have. And all that with less servers. So that's a nice thing. So where does that caching happen that I'm going to talk about? We have the internet, clients coming in, sending requests, and this square would be your domain, your hosting system. And instead of just having a web server with the application, you have a proxy in front of it, which looks at every request that's coming in, and it decides, can I find the answer to that request? Can I find it in the cache? If it does, it just replies the answer. It doesn't even touch your web application. And this is what you want to achieve. This is when it's fast. And otherwise, it notices, oh, I can't, so it goes to the application, gets a response, and if it decides that the response can be cached, it will store it for next time. And when you're doing caching, and that's what we will talk about today, is you want to increase the part of your responses that you can give directly without going to the back end. That's what you want to achieve. So just a quick glance. We won't need all the details of this anyway, but that's how you can imagine, or how you can see how Varnish, the Varnish cache works. You have a request coming in. You decide whether you want to look that up in the cache, so whether the request itself can even be cached or not. And if it's not cacheable, you just go to the backend in Varnish and get a response, deliver that. Otherwise, you go to the cache, you check, is it in the cache? If it's not, you have to fetch the content from the backend and put it in the cache, and then you can deliver it. If it was in the cache, you directly go here without going to the backend. Now, Varnish will only ever attempt to cache, so that's in this step here, if it's a GET request or a head request. If it's a post or delete or something, it says, well, there is no point in trying to cache that because it's going to modify server state. So it's extremely likely that you want that request to go to the backend. It never caches requests that carry a cookie or authorization header by default. It never caches a response which tries to set a cookie, and it doesn't, or it only caches if the response status is one of the responses it considers safe. And you can change all of this. And what we're talking about today is this one. Because if you have something, let's say a newspaper website where you have logged in users that have the permission to read the articles, it means everybody who's logged in needs to be identified in a way, so usually that's cookies. If you have an API that you provide, it might be the basic authentication header. And as soon as you have that, by default, Varnish can't cache anymore because you would need to take extra considerations. So when you have sessions on your web applications, there's a few things you can do depending on your application, depending on what makes sense. One is to just avoid having the session or only start the session when you need it and then stop it again. So let's say you have like an anonymous website for anonymous users, but there is one section where you need to be logged in. Try to restrict the session to that subpath. Or you have some form where you need a cookie to track the user, and then when he's done with the form, you don't need the session anymore, delete the session again. Or you could force Varnish to do cache lookups, even though there is cookies, but then your backend will need to make sure that Varnish is not caching the wrong thing in the wrong way, or you end up with a huge mess. And then finally, there is this idea of user context. I will talk, the second half of my talk will be about that. But the basic idea, to speak in this newspaper idea, is that actually the caching, you can separate that between cache for the anonymous user, who maybe he just sees the information or teasers, but he cannot read the articles, and then the logged in users that are authorized to see the articles. And in this example, let's say you really have just these two groups. So basically you need just two versions to be cached, because every user is either one or the other. And this user context idea is about how to achieve this, because on Varnish what you see is a cookie that says like that's his session. It doesn't even really tell you if he's logged in or not in the application. So first one, avoiding the sessions. It's kind of the lazy thing. I put that in for you, Larry. That's it's kind of, if you can avoid the sessions to increase caching, do it, because it's really the easiest you can do, the least dangerous. In the worst case, what will happen is that occasionally something isn't cached, which isn't dramatic. So if you have cookies, as soon as you don't need the cookie anymore, if you don't need the session anymore, delete the cookie, remove it in PHP. If you use some framework, there is probably something in your framework to do that. That would be the pure PHP thing, to delete the session. If you're doing things like, for example, in Symfony, there is this thing, if you access the I think it's called app.session, it starts a session even if there was none. So there are, watch out for your framework to be sure that it doesn't accidentally start a session if you don't want the sessions. And one thing you want to do, well, that's the Varnish specific thing, how you do it. If you have some other caching proxy, it will be something else. But you want to look what kind of cookies you actually have. So this thing is about removing all but the session cookie. And the thing is, if you have, for example, Google Analytics in your page, Google Analytics will do JavaScript cookies, and the browser sees like, oh, I have a cookie with this server, so it happily sends all these tracking information about Google Analytics to your server, and your server doesn't care about those, it doesn't need them, but still, if they're in this header, then Varnish sees, oh, there is cookies, so I cannot cache anymore. So what we do here is, it's a bit small to read, but you find that in the Varnish documentation. Basically, it's a series of regular expressions to only keep the cookie called PHP sess ID, which is the default session name. And then in the end, it checks if the cookie is now empty, which would mean there was no session ID, only other cookies. And then it can remove the whole cookie header, and your request becomes cacheable. So next thing would be looking up in the cache even though there is cookies, and it's very easy to mess that up. It can make sense, but you have to be careful because like the one thing you really don't want is I go to that page with my cookie, it shows the information for me, it shows, I don't know, like hello David and whatnot, and then somebody else, one of you comes to the page, and you get that page from the cache, and it tells you, hello, David. And chances that you're called David is pretty small. And there is like more severe problems than just the name. So the problem really is if you start, you have to avoid mixing content for the logged in users. So the idea, if you do this, would be that the backend knows on this response what kind of caching is possible. So it can send the header to tell, like, hey, this page is not cacheable. Don't cache it. That's fine. If you have to do that all the time, then you can also just not put the Varnish because it won't help you anything if it never caches. Another thing it can do is using this vary header that's a construct in HTTP to tell the cache that the response to a certain request depends on a specific header that was in the request. So if you say, like, depending on the cookie, my response will be different, Varnish can cache that. But for every different cookie, it will be a separate cache. Now, if you have the session ID as the cookie you use, it's only like an edge case where that can make sense. If you do that for the whole page, you're basically caching, have like one cache for every single user. So you'll have very few cache hits. Your cache will just be full and have to throw out old pages. And basically, usually what you want to do is sending the max age, that is telling the client how long it can cache, and make the client cache these things rather than Varnish. But in some situations, it can make sense. If you have some fragments of a page, for example, or some AJAX call, where you say, like, this specific call depends on the cookies and the other don't, then it can make sense. But then what you want to achieve in this scenario is that most of the pages delivered by your application actually don't depend on a cookie and could just say, hey, this can be cached. But the dangerous thing, again, is if you put this line, like this header, but actually you did look at the cookie and the cookie did matter, then you messed up the cache. On Varnish side, if you want to make this happen, like make it cache content even though there was a cookie, what you will do is you look at there is a file built in VCL which defines the default behavior of Varnish. And that's quite cool. You can read that. It's in the configuration language of Varnish. And it tells you exactly what Varnish will do by default. And you will find in the receive, so this function that gets called when the request comes in, you will find like a lot of sanity checks and whatnot, and at some point you find this, oh, if the request method is not get, it's also not head, then we go into the pass state, which means we don't try to use the cache. And then that's fine, but the next line says, oh, and if there is an authorization header or a cookie header, we again don't cache. And what you want to do is you copy these checks here, but you remove the last one that said if there is a cookie or authorization, and you just say return hash, which means we go to the cache. And suddenly we will start caching requests even if they have a cookie. So this user context thing, I was trying to think how to illustrate that and came up with this idea of the different queues at an airport. So most airports do this, like, oh, if you have a European Union passport, here like the small text is like Switzerland and other random countries that are not in the European Union, then you can use this queue. If you're somewhere else, then use the other queue. And user context is kind of the same idea. It's a group-based caching, so we want to split our users into as few as possible groups so that we can cache once for each group. What's quite cool, if you have an existing application, it is transparent for your application. You don't need to change all the logic, all the permission logic in the application, because the proxy, the caching proxy, is helping you. So the basic idea is that the caching proxy is requesting some sort of hash from the backend using the original request with the cookie. So the backend can use the cookie, restore the session, and see, for example, that's like the permission set of that user, or that is the roles of this user. And based on that information, it generates some hash, which is just, the only criteria is that it needs to be unique for each combination of permissions. And that hash, like how you generate that, there is a PHP library that helps you do it, but you can generate that in any way that makes sense for you. And that hash would vary by the cookie or by the authorization header. It varies by the credentials of the user because it's specific to that user. But once that hash is calculated, it's cached, so the next time it can just be reused. And then the request is done. So in the illustration, we have this request which has credentials on it. We do the hash lookup from the cache to the application. The application knows about users. It knows what to do with these credentials. It can decide, like, well, that's invalid credentials, you're anonymous. And that response will vary on the credentials. It's individual. And then we do the actual request. We don't remove the credentials from the request, but we add the hash. And if the backend can provide the page only, like if the page only depends on the permissions of the user, but not on the individual user, it can say, well, my response now, it varies on the hash. It doesn't vary on the individual credentials. It's only depending on the hash. So we have the browser requesting a page. We have the proxy requesting the hash. Hash is calculated, returned, and now there is the actual request, with the added thing with this hash. And the response that says, hey, we depend on the hash. And then we deliver that. Like in this case, we only added overhead. But next time the same user does a request for some other URL, we already have the hash in the cache. So at this point, let's say we don't find the actual page in the cache, but we had the hash. So the overhead after the first request is really small. It's just a cache lookup. And Varnish is really fast in doing cache lookups. It gets really cool if we already have the page in the variant for that hash. Because then, even if that user has never requested this specific page before, but some other user who is in the same group has requested it, we can reuse that cache and return the page. So this is where we want to go. All right. So real life, usually it's more complicated than just the nice example that I'm talking about. I took a website you might have heard about or might have visited before. And there is like all kind of stuff on this page, like the description of this ticket. Well, in this case, it's public because it's an open source repository, but GitHub also has private repositories. So suddenly, even this thing is not, like in general, you cannot say, or the cache cannot say that this part is public in any case. So maybe this could be a use case for the context, and the hash would be something like which organizations is the user member of. And if you're a member of the organization that is allowed to see this, you get this page. If you're not, you get some page that says, I guess, like, oh, not found, because you don't want to even reveal the fact that there would be something under that URL. But then there is all kinds of other bits, like up here, there is my face and some thing that tries to tell me there is some notification. So that's personal information. Actually, it is not specific to this page. On every GitHub page, I have this header, and it always shows me who I am. I can access my profile, or I could go to my notifications. So this part could be cached with a vary on cookie, because this part will be the same each time I load a page. And there is this thing. It's specific to me, because it needs to know, do I currently watch or not? But it's also specific to the repository, because it's like, do I watch this repository? And then there is stuff like I can edit here, I can edit here, I can do stuff here, here, here. And that is my role within this repository. So the point I'm trying to get at is, if we look at the whole thing, and the caching happens on page level in HTTP, we can actually not cache, because everything has there is lots of different criteria. Now, I'm not working for GitHub, just to avoid confusion, and I'm pretty sure what they do is mainly lots of JavaScript. But I'm just using it as an example to show you what could be done. So basically, when we have this, okay, there is a page, but some parts of it would have a different caching strategy. One thing we could use is edge side includes. Who has heard of edge side includes? Who has used them before? Okay, so the standard was introduced, I think, by Akamai for defining how you would, or how to say, for allowing your cache to assemble a page in the cache, which has the benefit that every part of that page can be cached separately. Another thing you can do is go for Ajax. So like just load some parts of the page asynchronously in JavaScript. Like, I don't know, you could load maybe this fragment here asynchronously. Or if it gets like as complex as these things, you probably want to go with just front-end application. You can just make JavaScript render the element to do this, because you need a ton of JavaScript anyway to make the features work here. So there is no point in having the server render that if you need to write the JavaScript anyway. So I'm quickly going to discuss all three of these options. So the edge side includes are really like a server side includes, like a require in PHP. You say on this particular point of my HTML, I want to copy whatever is found at some URL. So it's really like copy paste done by the cache. And the interesting thing is that the cache will fetch all these parts separately, and for each of them you can have specific caching rules that say like, okay, this part depends on the cookie, this other part cannot be cached at all, and this thing is like whatever you just cache it, it's the same for everybody. If you're doing Symfony, then it's nice to know that Symfony has a built-in support for the edge side includes, which makes it really convenient to work with it. In HTML, it really looks quite simple. You have this tag, and like everything between these, or like these parentheses and everything between, will be replaced by Varnish with whatever is the output of fragment.php. And this URL is just relative to the requested URL. On Varnish side, you need to activate it. One thing is that on the request, you add a header that tells the backend, hey, there is something in front of you that knows about ESI. So if you're using Symfony, for example, it will check for this header, and if it's there, it will output the ESI tag. If it's not there, it will do the ESI itself so that you can run it without the cache in front as well. And then when you get the response from the backend, you check if the backend was saying like, hey, I actually did ESI. Then you remove that header because you don't want to spill that information out to the world. And you activate ESI for this response, and this will, like the rest, will be handled by Varnish. Varnish will go and parse the content of the response and look for these ESI tags. So as I said, the main thing we want is this separate caching rules for different parts of the page. It is server-side, so your SEO people will love you for that. They will be happy because search engines will see the whole page. And in your application, you don't need to like completely rebuild or remodel your application to do that. Like the major drawback with it is that Varnish will have to resolve all of these ESI before it can send the response. Now, if you say like, oh, I have this thing, I have this e-commerce maybe with a list of 50 products, so I just do an ESI for every product because they can be in different lists, in different orders. In the worst case, when you have a cold cache with no data in it, it would mean that the product list is cold, and then you have 50 requests going one after the other to the backend to get each fragment for a product. And depending on your application, that can really hurt, and it's probably quite slow. And Varnish cannot send a response before it has resolved all these ESI calls. Who of you is using Symfony in here? Okay. So just quickly, in Symfony, you would enable it with configuration, and then in your Twig templates, there is a special syntax to tell, like, hey, render me this part as ESI if there is a ESI-capable cache in front of you. Otherwise, Symfony itself will resolve it for you. Now, in those cases where, well, I don't know, like the e-commerce example, you could say, well, my page renders the first 12 products maybe, and then there will be more, but I don't render them yet. But when the page is loaded, we have JavaScript, and we just put in the content of the page, we put the information for JavaScript to know, hey, you have to load these other products. So if these others are below the screen, the user will not even notice that he doesn't get them right away. So you would have some endpoint that can just serve HTML fragments to the client, and you have some JavaScript that loads that. The main benefit, or one of the main benefits, is that this can lead to a faster page load. You can just deliver something, the user already sees something, and then maybe even one after the other additional information is added to the page. If you have some kind of non-critical, or it's not the main thing the user wants to see, but some additional information, I don't know, like related links to this article, something that is not the first thing the user wants to see, and especially if that is slow, then Ajax is interesting. There is several cons on that. One is the network overhead. If you're on a mobile where that matters a lot, each request response thing, it's not so cool. It requires you to kind of change your application. With this example of the product list, you will have one way to render a product directly in the page, but also another way to render it in a separate fragment for Ajax. So it makes it more complicated. You have to change your application. And the SEO people will not like you anymore. And that can be a severe problem for some things. For some, not for others. If the Ajax block is anyway only for logged-in users, for example, who cares? Because the search engines are not logged in. But if it's that product list, then maybe that could be a problem. Front-end applications, I'm not a front-end developer, but the idea is really you have this response that somehow communicates the user state, like is he allowed to edit things? So that could be how it looks on the GitHub page. When the page is loaded, it starts to do stuff on the front end. And well, one thing is you can enable little things all over the page without, it doesn't cost you more if the buttons are splattered all over the page. It's not like with Ajax where you have a request for every piece that you want to show. And there is no network overhead, so there is no additional load on the back end. And especially with complex user interfaces these days, it's way more convenient. It's also way more faster because you will save on later round trips. Unless you want to go all out JavaScript rendering and whatnot, it's not that suitable for HTML fragments. You will need people who know how to do that. You will need the effort to build all that stuff and to maintain it. If it's this kind of application thing, then again, search engines probably don't matter. If they would matter, then it's not the right thing. So that will be it from my side, and I think we have time for a few questions.
Hello. How does the invalidation works?
You mean the invalidation in Varnish?
Yeah.
Well, you have different possibilities how to invalidate. Well, to say that. So if you're using the user context, there is one validation method that Varnish calls purge, which you say this specific URL, I want to get rid of that URL, and that gets rid of all the variants of the URL. So if you have the user context, if you have that hash and it was varying on the hash, it would mean that all variants that were cached of that specific page get invalidated. Another method that it knows is called banning. With banning, you tell Varnish to consider invalid everything that matches a regular expression. And you can regular expression match on the request URL, but also on all kind of headers. So I don't know, for example, if you have some special situation, you could ban everything for a specific hash, or you could you could ban the hash of a specific user because he logged out or because he was promoted to a different role. So you would calculate that you would look what the cookie of that user is and go and invalidate that specific user.
Can I have a question?
Uh-huh.
Can be cached the fragment of pages?
Sorry?
Can be cached the fragment of pages you included?
You mean the ESI fragments? Or?
For fragments included by the instruction.
Yes, exactly. Each thing, so if in the example that I
Even
had,
included in Etsy.
Yep. I'm trying to find the ESI, this one. So here you say there is fragment PHP. Varnish will see this.
On
it does
this,
a request.
as I refer.
It does a request on fragment PHP.
This.
And the response to that fragment can be cached. It has its own, it's considered like a request again. So
Is consider a request this?
it's its own, it has its own caching rules. So you could cache the main page and not cache this, or you could say, well, this thing I cannot cache, but this part I can. You can have all combinations you want.
And the fragment can have other fragments at all. Yes?
You can nest this, but I would recommend to not go overboard, because Varnish will have to do a request for every fragment. So if you have, I don't know, if you really go very complex and you have 100 ESI things and including things that include other things, you will have a lot of requests, and it's more expensive than just including a file. So if you have too many includes in one response, it will get slow again. But you can include inside a fragment, you can include another ESI.